I'm Alex Craig. I'm an assistant professor here at the University of Arizona, and my background is high-speed wind tunnel experiments. And so this is the boundary layer stability and transition laboratory. Our focus is on the transition from laminar to turbulent flows and adjacent phenomena, aerodynamic heating, things of that sort, within this sort of high-speed Mach 4, Mach 5 kind of range boundary layers. And so today we're here to show you our wind tunnel complex. And we've got a smaller scale Mach 4 tunnel here on my left and a larger scale brand new Mach 5 tunnel here on the right. And we're really excited about this new capability that we're bringing online. So this is the older of our two wind tunnels. This is the Mach 4 quiet Ludwig tube. And if you're not familiar, Ludwig tubes are a short duration type of high-speed wind tunnel that operate for about 100 milliseconds in this case at a time. And for our types of experiments, that's an eternity, even though it might seem like a very brief period of time. Now, this tunnel is fairly small. It's 4.3 by 3.8 inches in its test section. And so it's primarily focused on basic research, fundamental science. And this is what we call the quiet tunnel. The general idea here is that you can basically make the free stream of these tunnels more closely approximate what you would encounter in flight, so that when you go to study this boundary layer transition problem, the physics that you see on your model more closely resembles the sort of thing that you might see on a vehicle in flight. And for reference, a more conventional wind tunnel would have a noise level in the free stream of something on the order of 1% to 3% pressure fluctuations. A tunnel like this is going to have pressure fluctuations that are on the order of maybe 100 times less than that. So generally speaking, we say it's less than 1/10%. It usually is several hundredths of a percent. And so this was the first tunnel that we brought online here. It's actually a re-established tunnel that was built back in the 90s at another university. And we put this back together, and now it's running full speed again. So this is our new tunnel. This is the one that we're really, really excited about now that it's online. This is the Mach 5 Ludwig tube. As you can probably tell, it's another Ludwig tube design, again with about 100 milliseconds of constant condition runtime. This one, on the other hand, is 15 inches in diameter. And so we've specifically designed this to be large enough that we can sort of straddle the realm between basic research and applied research. And that's really what our goal is with this one. So this tunnel is brand new here at the University of Arizona. We designed it, started designing it when I started about 4.5 years ago. And just recently, within the last couple of months here at the end of 2020, we've finally declared it fully operational. So we now have our first set of new science slated to come out of this tunnel, and we're pretty excited about that. What we can do in this tunnel, and in the smaller tunnel, but this one especially, is we've got 32 different channels worth of pressure and other resonant transducers that we can handle. We have 64 channels worth of thermocouples that we can handle. We do Schlieren. You can see this light box behind me. That's our high-speed focusing Schlieren system that we can take images up to 2.1 million frames per second. And on the other side, you can see the camera that does that, along with our IR camera, our infrared camera, so that we can do surface thermography, so that we can work out what the temperature field on the surface of a model is, or, for example, convert that into heat flux, which is, of course, of intense interest when you're talking about vehicles flying at these speeds. And moving into the future, we certainly have the capability of adding more channels, and that's something we'd like to do moving forward. And we're also working on trying to develop a fast response force and moment capability here. So the idea would be, even though we've only got 100 milliseconds worth of runtime, which is an eternity from the physics standpoint here, we can actually, hopefully in that time frame, start to measure more integral quantities like forces and moments that you might typically associate with longer duration tunnels and that have historically not really been doable in a facility of this type.